we will be finding the reflected H field now. So when working with reflected or transmitted, we need to work with the loss tangent. And that's an important part of problems like these. So loss tangent is given as sigma omega epsilon, sigma omega epsilon naught, epsilon r. That's what this is made out of. It has two parts. So this is going to be 0.4 over 10 to the 11 multiplied by e of 0, which is given as 8.8 something, but I like to use 10 to the negative 9 over 36 pi. Epsilon r is 81. So we're going to have a 0.005 low loss. It's important to know that when doing problems like these, it is never ever in between 0.01 to 100. Okay, we do not work with general materials in this class. No general material, not good. Okay, so with that, we need to use Snell's law to find the gamma. So using Snell's law, we have n of incident, sine of incident equals n of t, sine of t. So 1 in there, sine of incident is going to be 53 degrees, because Snell's law, we need to use the angle that's normal to the plane. So this is our thing down plane down here, and this is normal to it. So we're going to be taking this angle here, 53 degrees. So n of transmitted and is going to our n of t. Our n of t is found through E of r. So n is equal to the square root of E of r. And the square root of E of r is going to be 9. So we have 9 sine of t. And like that, we have everything we need to find the angle. So the angle of t is going to be the sine inverse of sine 53 degrees over 9. And that's going to give us a 5.09. And this can be our angle transmitted. Okay, so gamma perpendicular is given as n1 cosine I minus n2 cosine of t, and on the bottom is going to be the same thing, plus n2 cosine of t. The only difference is that they add each other. So for gamma per parallel is going to be the same thing, but n of I cosine of t minus n2 cosine of I. Only the thetas swap, and on the bottom is going to be plus, and the same thing is reflected down there. So we're going to have cosine of 53 minus 9 cosine of 5.09. The bottom part is going to be just the sum of those two. The top is the difference, and the bottom is the sum. So on the bottom, we're going to have cosine 5.09 cosine of 53 degrees, and we're going to be adding those up together. So calculate that, we're going to get negative 0.874. Okay, and this is going to be negative 0.7 689. And our gammas are found. And that's going to help us on finding the reflected H field. So let's find the R of this one. We found the R earlier on this. We need to find the R in this now. So the R is still going to be in the negative X direction, but it's reflected up. So we should be seeing a positive Z, negative X. So let's figure that out. We got negative X, cosine of 37 degrees. We're going to be using this angle here. So the opposite is going, the X is in the cosine component. So it's going negative, and then the Z should be plus Z hat sine of 37 degrees. And that's going to equal to negative 0.8 X plus Z 0.6, and multiply all that by the same K as we found earlier. So looking for the H reflected and E reflected, we're going to be using E of R reflected to find the H reflected. So of Y hat 10 multiplied by the gamma perpendicular, cosine of 10. Because they're in phase, all of this is going to be the same, minus 200Z. Doing the math, ER of 1 would equal to Y hat 8.74 cosine 10 to 11t so that's our E of R1, negative, because from the perpendicular gamma. To find HR of 1, we need the direction, the E naught, gamma perpendicular over eta naught, because we're still in there, as seen in this diagram. This is air up here, and water is down here. We have cosine 10 to 11 plus 267 x minus 200 z. So by doing the math, we already know the direction is going to be in the negative y direction, and that from reflection we go from right hand or RHCP to left hand circular polarization. So our E is going to be going out of the page. ER of 1. And using our left hand for this right hand rule, we're going to have K going up, but E is pointing out. So our H is going to be pointing down this way. So this is our HR of 1. And our HR of 1, if this is 37 degrees, this is going to be 37 degrees. You can also see that these lines are parallel, and these are angles that are going to be the same. So this is 53. So that makes a 90, and the remaining is going to be 37 here. So we have 37. So we're going to use trigonometry to find these angles here, to find the x and y component. So our HR of 1 is going to equal to negative x sine of 37 minus z cosine of 37. And then we're going to have our eta naught and gamma. So 8.74 over 377. And cosine of the same stuff, because it's all in phase. We're going to get negative x 0.6 minus z hat 0.8 0.74 over 377 cosine. plugging that in the calculator, we're going to get x hat 0.0139 plus z hat 0.0185 cosine 10 to 11 minus 200z. And that's going to get us our HR of 1. Next, we need to find HR of 2. So, HR of 2, using our left hand to find the HR of 2, we're going to have K pointing, our thumb is going to be pointing this way. Our fingers are going to be pointing down, so we know that our HR of 2 is going to be into the page in the Y direction. That's our assumed. So our HR of 2 is calculated using the direction eta naught gamma 377 sine 10 to the 11t plus 267x minus 200z. Okay, so we have y hat, and then we have 10 multiplied by the perpendicular, which is negative 8.74, over 377 sine of 10 to 11t plus 267, and our HR of 2 is actually going to be in the negative y direction. Negative y 0.0182 cosine of 10 to 11 t plus 267x minus 200z. And that's going to be our HR1. Oh yes, and these are in amps per meter. I forgot about that.